Good morning, all. How are we doing this morning? Sorry about the mix-up in the times. I say something one time and then I get a different idea. Sorry about that. We're going to go back to the worksheet that you had for today. Ask you to do some problems. I'm going to go to the last one. And calculate the net force and acceleration of the object. Which direction is the object moving? Okay. The problem is we don't know which direction the object is moving here. We have a force applied going to the right here, but we have this mass also that's pulling downwards. So we need to know which direction our mass is moving. Okay, is this moving to the right or is it moving to the left? Okay, and this object, is it moving up or is it moving down? We have to figure that out. So we have to start analyzing the forces that we have here. Our force pulling downwards, we have a 10 kilogram mass. What would be the force? What is the force of that object pulling downwards? Liam, what is the force of the object pulling downwards?
98.1.
98.1. Taking the 10 kilograms times 9.81 meters per second squared. So this force of gravity, which is weight, is 98.1 figs. And this is being transferred also through the rope in this hopefully frictionless pulley system. So this force of 98.1 newtons is pulling it through a frictionless pulley to the left. We have 20 newtons pulling to the right. So we first need to determine which direction this object is moving. Okay, we still have this, also the force of friction. So we have our force normal we have to worry about. And our force normal, since we are pulling horizontally here and the object is moving horizontally, we're not pulling upwards, going in this direction, pulling upwards or pushing downwards on the object. We're just pulling it sideways. This force normal will also equal our weight. Test what is the force normal and also our weight of this object here.
$294.3.
I'm sorry, what did you say?
294.3.
And we found that by taking 30 kilograms times our 9.81 meters per second squared. So we have 294 newtons that are pulling it downwards. So if we take a look what's occurring here, I got 20 newtons pulling to the right, I got 58 or 98.1 newtons pulling to the left. I have a coefficient of friction, which is 0.10. I have a force normal, which is 294.3 newtons. We can also, if we want to right now, calculate our force of friction. Our force of friction is calculated by mu times force normal. So we have 0.1 times our 294.3 newtons. Andrew, did you make it in? Dylan, what did we get our force of friction to be?
29.43 newtons.
Okay, so we have 29.43 newtons. Now, we have to remember this force of friction is only going to work against the motion. Okay, it's not going to determine which direction our motion is going. It's only going to go opposite whatever our motion is. So if the object is being pulled to the right, okay, it's going to go 29.43 newtons to the left, just because it's going to counteract motion. But if the motion is going to the left here, okay, then my force of friction is going to go to the right because it's going to be opposite the motion. Well, if I'm pulling at 98.1 newtons to the left, I'm pulling at 20 newtons to the right, which direction is this object going to move? Anna, which direction is this object going to move?
To the right.
To the right, it's going to go in this direction with the 20 newtons. I have 98.1 newtons pulling to the left. I have 20 newtons that are pulling to the right.
To the left.
It's going to go to the left. Get my point in there. So I have 98.1 newtons going to the left and 20 newtons going to the right. So this object is going to move to the left. So if I start summing my forces in the horizontal direction, once again, I look at motion, and even though it's moving to the left, I look at motion as being in a positive direction. Whatever your motion is going to be. So our motion is going to go to the left. Why? Because there's 98.1 newtons pulling to the left, and I have 20 newtons pulling to the right. So I look at whatever your motion is, whatever the motion is, that's going to be my positive direction. So we have 98.1 newtons here. Then we have a negative 20 newtons because it's going to the right. That's opposite the motion. And now we can incorporate our force of friction. Because our force of friction is going to go opposite the motion. So my force of friction is going to be going to the right. So if it's going to the right, then I have a negative 29.43 newtons here. So this is my force of friction, or this is my force applied going to the right, left, force applied going to the right, and here's my force of friction. So my net force would be what, Ozzy?
48.67 newtons to the left.
48.67 newtons, and that's going to the left because that's where my motion is. So that gives me my net force. Okay, which direction it's moving? We're moving to the left, and now we want to find the acceleration of the object. So we have force net is equal to mass times acceleration. So we have the 48.67 newtons here is equal to mass times acceleration. But if I'm dealing with my mass, what is the mass that is being moved to the left here? What is our mass? So how do I just use the 30 kilograms here, or what do we do with the mass, Liam?
You add the weight of the thing on the end of the pulley to 10 kilograms.
Okay, so we're going to have a total of 40 kilograms here, and this comes from the 30 plus 10 kilograms. Because both these objects, once again, are moving. Okay, it's not a bungee cord where it's starting to stretch or anything like that. Both these objects are moving to the left and downwards. Even though this is not moving to the left, it's still moving in this direction. So we can divide by 40, divide by 40. So our acceleration of this object is 48.67 divided by 40. .22 meters per second squared. Questions about that? right, let's take a look at the next day of notes. Okay, it says 4.5, inclined plane problem. We have a 20 kilogram mass on a frictionless plane. Calculate the net force and the acceleration. And now we are frictionless here. Okay, so this goes back to what we talked about before. This is a frictionless plane. We are on smooth ice. Think of it that way. You're walking down a ramp or a plane on smooth ice, and you are on roller skates. There we go. There is an image for you. Rob Deerdack and the ridiculousness would be all over that. You are walking down a plane that is smooth ice on roller skates. That's getting close to frictionless there. Calculate the net force and acceleration. Well, we have 20 kilograms. If remember, we have our weight going downwards, and we have our two components. We have our normal force, and we have our parallel force. So we have our force parallel and our force perpendicular. We have our force of gravity. And this angle here, once again, will go up there in the triangle. We have a 20 kilogram mass, so go ahead and calculate your force of gravity first off. Then find your force parallel and your force perpendicular. Lucas, what's our force of gravity?
196.2.
Okay, that's our force of gravity. Our force parallel, when we deal with force parallel, Dylan, are we using sine or cosine?
Cosine?
Cosine for force parallel. Here's my 35 degrees.
Sine?
Sine. Okay, and force perpendicular would be cosine. What do we get for a force parallel, Dylan?
112.54.
And force perpendicular?
160.72.
Everybody good with those? Let's calculate our net force going down the plane. Well, our net force, the only thing that's pushing it down the plane, once again, is just our parallel force. Okay, our parallel force is the only one that's sliding this thing down the plane. So my force that's being pulled down the plane is 112.54. That is our net force. That is our net force that's making it slide down the plane. Then acceleration. force net times mass times acceleration, or equals mass times acceleration. We have 20 kilograms times our acceleration A. And this is something that, once again, this goes back to just what we did in the previous quiz. We can divide both sides by 20. And we get 5.63 meters per second squared. But once again, as we've talked about before, we know in this world that everything is not frictionless. So we need to now deal with the friction. We now have friction. We have the exact same thing. We have 20 kilograms. We have a 35-degree angle here. We have now mu is equal to 0.10. So our setup is going to be the same initially. Where we have our force of gravity, our force parallel, and our force perpendicular, which is also our force normal. Those are all still going to be the same. We still have a 20 kilogram mass, so our force of gravity is still going to be the same, the 196.2. Our force parallel is still going to be the same. Our 35-degree angle transfers up to here. So our force parallel is 112.54 newtons. And our force perpendicular is 160.72 newtons. Now this force perpendicular and this force normal, they are the same thing. But now what we have is we have friction. We have friction. So we have, this is sliding down the plane. We have the force of friction that's going to go against our motion. So we have to calculate our force of friction as mu times force normal. So go ahead and calculate your force of friction. Our force of friction comes down to what, Riley?
16.1.
So we have 16.1 newtons that's going to resist motion. Once again, friction is the resistance to motion. It goes opposite the direction of motion. So what we have here is we have a force parallel that is sliding this down the plane, which is 112.54 newtons. That's sliding it down the plane. We have this force of friction that is resisting this motion. So we have motion going down the plane. And the force parallel is the thing that's pulling it down the plane. Force of friction is the one that's resisting our motion. And that's 16.1 newtons. So if we sum to find our net force in motion, in the direction of motion, we have the sum of forces is our force net in the direction of motion. Once again, we take motion to be a positive direction. Friction then would be in negative direction. Katie, what do you get your net force to be?
I got 96.44.
96 newtons. So once we find that, we can now find our force net is equal to mass times acceleration, which we have 20 kilograms, times our acceleration. We can divide that by 20. Brandon, what do you get for your acceleration?
4.82 meters per second squared.
Questions? All right, just add a 10 kilogram mass to the other end. We have mu is equal to 0.10. We still want to break this down into two components. Those two components are going to be the same. We're still dealing with a 20 kilogram mass. We have 196.2. This is still 35 degrees. Let's see, 160.72. And 112.54. We can still deal with our force of friction, still going to be the same amount. So we have 0.1 times 160.72. So we have our force of friction is 16.1 newtons. But we have this 10 kilogram mass, which is going to apply a force. Of 198 newtons. That's going to, once again, transfer through this rope at 98.1 newtons. The question is, which direction is this mass going to move? Which direction does it want to move? Oh boy, I'm going to run into a problem here. Ozzy, which direction does this object want to move? Down the plane or up the plane?
Down the plane?
Down the plane, yeah, because my force parallel is 112.54. My force from this weight is 98.1 newtons. Oh boy. 114. Which means my force of friction is going to go that way, and that's going to be too much for my parallel force. Oh, let's alter this a little bit. Let's make this 8 kilograms. And 8 kilograms. So we have 8 times 9.81. That's 78.48 newtons. 864, carry the 6. 9 times 8 is 72, 78.4 newtons. Sorry about that. My problem would not have worked out. So we have 78.48 newtons. We're still going to have motion going down the plane. So if it's going to go down the plane because my tug of war is going to push it down the plane, that means my force of friction then has to go opposite that. So my force of friction is going to be the 16.1 newtons there. Why I had to alter this is because two of my forces is 98.1 and 16.1 would have added up to 114.2, which is greater than 112.54. The object would not have been moving because my force of friction was too great. I want the object to move here a little bit. So if we take a look at our net force, go ahead and find the sum of your forces in the direction of your motion. Find your net force and then find your acceleration. Our net force, Bennett, are you in there? What would be our net force?
Yep. 88.96.
88.96. I have 112, negative 16.1, and negative 78.48.
I typed it in wrong. $17.96.
17.9. Whoopsie. Newtons. So once again, this is equal to mass times acceleration. And as we dealt with respect to the problem I gave you, that has to be a total mass. So we have a total of 8 plus 20. Kilograms times acceleration. So we divide by 28, divide by 28. So we have 17.9 divided by 20.8. Or divided by 28. So we have 6.64 meters per second squared. When dealing with the force of friction, it just adds another component, but always think about force of friction is going to be opposite your motion. Whatever your motion is, it's opposite that. It does not figure into what direction the object is moving. It won't figure into that, but it will figure into once it gets moving, it's the force that's acting upon the motion. And that's why it's called kinetic. When you talk about kinetic motion are objects that are in motion, objects that are moving. When you're talking about kinetics, you're talking about moving objects. So when you're dealing with kinetic, you're going to have sliding friction that's involved in that. Okay, what I'm going to do is I'm going to post some homework for you. Okay, this will be due at the end of the chapter, but we can start working on our homework problems now. This completes everything that we need to complete in regards to this for this chapter. Monday we'll come in, we'll deal with some additional problems. I'll have some additional problems for you we'll work on together. But once again, the homework I will start posting, and that will be due on the chapter test. And I'll look for the chapter test next week, maybe on Friday next week. It depends. I'm trying to split it from my other classes. But we will have a chapter test. We may even get a quiz in here and then a chapter test just to get us another grade. So Monday will be a little bit of a review of some types of problems. Here, this is what we'll do. Monday, we will review some problems and have a review. Wednesday, we will have a quiz over friction. Friday will be a review over the chapter. And then the following Monday, we'll have a chapter 4 test. So that will be our schedule for next week and the following week. We can get a quiz in there that will give us another grade for the 9 weeks, which I'm trying to get. Since we typically do a lab over this material also, that obviously is not going to happen in where we're at right now. So let's get a quiz in on Wednesday of next week over just friction, and then we'll have a chapter test the following Monday over chapter 4. Questions? And this Friday here will just be a review. All right, I have nothing else for us today. Thanks for attending. Have a good weekend. Stay safe, stay out of trouble. Cheer on Ohio State. Oh, that's right, they're not playing. Did they get into the Big Ten championship?
Yes.
Yeah, they did. Well, that's good. I'm glad they wised up. And you think about the logic. Even if they would have got beat by Michigan, which wouldn't have happened, but even if they would have still won the tiebreaker with Indiana. So because they beat Indiana, so to me it's a moot point. The game outside of tradition and always wanting to beat up on Michigan, and just to watch the Jim Harbaugh camera. It's always enjoyable. So have a good weekend. Stay safe, stay out of trouble. Once again, I'll post some homework to go with these notes that you can start working on for the chapter then. Other than that, adios. I'm out of here. Have a good weekend.
Appreciate it.
Yep.
I don't know.